In this video, we're going to discuss the reactions of amines and amides. Let's begin with amines. An amine comes in a variety. There are primary amines, secondary amines, and tertiary amines. To make an amine, to synthesize, a general reaction for this is to have ammonia plus a haloalkane. So if I have a chloroalkane, or even bromoiodo and the like, some halogen on an alkane, what can happen is the nitrogen can attack the carbon with the halide, shoving that halide off. And so these arrows just kind of show you where they're going. They're not really part of our reactions in general. NH3 plus chloroethane. What will happen is I'll get a nitrogen. It still has two of its hydrogens, but it is now bonded to that carbon where the chlorine used to be, and the chlorine has picked up the lost hydrogen on the nitrogen. This has turned my ammonia into a primary amine, and if you do this a second time, I can go from a primary to a secondary. So ethanamine plus more chloroethane becomes ethylethanamine and more HCl. And you can do this a third time. Secondary will go to tertiary. So nitrogen with two ethyl groups plus another alkyl halide becomes ethylethanamine, or N,N-diethylethanamine, plus HCl. So you can make your primary, secondary, and tertiary amines through this process. And in fact, because each step is reasonably stepwise, you can mix and match the alkyl groups. The reason why they're reasonably stepwise is that amines are bases. If I have ethanamine and it sees HCl, it picks up that extra proton, becomes positively charged, has that chlorine for a negative charge, becomes an ammonium chloride salt. In this case, ethanammonium chloride. When you have an amine and it runs into an acid, it will react to destroy that acid. Amines are bases. This means every time you do one of our earlier steps, the reaction more or less stops. As soon as I create the amine and the HCl, they will react immediately to make the alkyl ammonium chloride. This then has to be cleaned up before it can be reacted a second time. And so it's quite easy to actually replace what each of the R groups is. You don't have to use the same one. You could start with ammonia plus chloromethane. This becomes methanamine and HCl. Because they would react with each other, this would stop reacting. You'd have to clean it up until you could get just your starting methanamine free again. You could then add to this an ethyl group with a halide. This would give you a methyl to the nitrogen, an ethyl, more HCl. You'd have to clean it up again, and then you could react that a third time with, let's say, an isopropyl with a chlorine. So 2-chloropropane reacts with it. You get a nitrogen with a methyl, with an ethyl, and an isopropyl. So you can easily mix and match what groups on your amine using this alkyl halide route. So this is how we can form our primary, secondary, and tertiary amines. Additionally, amines, as we said, are really good bases, so they pick up H+. But their best use after this is to form amides. The mean by which this has to happen is a carboxylic acid. So a carboxylic acid plus an amine can react with one another. That nitrogen attacks the carbon double bonded to oxygen, pushes out OH. This is a lot like ester formation. Remember that an amide has the general form R, carbon double bond oxygen, carbon to a nitrogen off to other R groups. This looks a whole lot like an ester. And the reaction to form it is basically identical. Instead of an alcohol attacking a carboxylic acid to form an ester, an amine attacks a carboxylic acid to form an amide. Depending on what amine you add, this will give you slightly different amides. So if I've got propanoic acid, and I have a methyl ethyl secondary amine, these will react to give nitrogen, methyl, ethyl, and, of course, water. So one of the hydrogens is lost on the amine. The OH is lost on the carboxylic acid. Those go together to form the water. And a new bond is formed from the carbon that was double bonded, and still is double bonded to the oxygen, but is now single bonded to the nitrogen instead of to the old OH. And so amines can be used in amide synthesis. Amides don't generally have reactions, unless you're breaking them down. Amides are remarkably stable. This is why they're so good for building proteins in the human body. The amide backbone is the key to protein structure in all life on Earth. And so in proteins, we'll discuss that in more depth, but they are remarkably resilient. They are just reactive enough that a good catalyst can break them, though. And so if you have an amide, let's use a simplified one. I can add water, and you definitely need some kind of catalyst. We'll use a generic acid catalyst with this water. But this can break it apart into a carboxylic acid and an amine. And so you can separate your amides. You can break them down back into the starting material. But this is about all you can do with your amide. They are remarkably resilient otherwise. And even accomplishing this takes significant catalysts and work. It is not a simple task to break an amide bond.